Let's go to page 174 and let's do number 218. Okay, it says find the number of diagonals that can be drawn in polygon of 100 sides. Okay, so yeah, n equal to 100. So to find the number of diagonals, okay, so since there are 100 sides, or means there are 100 vertices, so it'd be 100 choosing 2. Okay, so again there are 100 vertices, and you take any 2 vertices to make a segment. So this will give you total number of segments. Okay, so this will give total number of segments. Then you have to minus 100 of them because 100 of those segments would be sides. Okay, and so this will give you, and again the way to do this is this will give you 2 factorial with 2 and 1. And since there are 2 numbers on the top, you're going to get 2 numbers on the 2 numbers on the bottom. You get 2 numbers on the top. And so you're going to get 4950 minus 100. This will give you 4850. Now if you use the other formula, you're going to have n minus 3 times n over 2. Okay? And the reason for that is because, again, n minus 3 because the dot you cannot connect to itself, and you cannot connect to the side because those would be the side, not a diagonal. So n minus 3 would be those. You have to minus those 3, and so there are n combination, and you have to divide by 2 because this connect to this would be same as this connect to that. Okay, so you got 100 times 97 over 2. Again, so you work it out. Okay, so you can do it by either method. Okay, let's go to 219. Okay, 219, ABCDF is a regular hexagon with a side length of 6. Okay, so you got A, B, C, D, E, F, and each side is equal to 6. And you're looking for the area of the triangle BCE. So BCE. Okay, so you're looking for this area over here. Okay, well, all this would be 30-60 spatial triangles. Okay, and if you don't see that, what you can do is, okay, so you can get the exterior angle. So 360 divided by 6 sides, so you get 60 degrees. So exterior angle is 60 degrees. Therefore, this would be 120. And since this is the bisector, so you get 60 and 60. Okay. And this is going to be a right angle. So this is going to be 30-60 spatial triangles. So if this is 6, this would be a 12. And this would be 6 squared root of 3. Okay, so the area of this would be 1/2 base times height. So the area will equal to 18 square root of 3. Okay, let's go to 220. Okay, so 220. It is 2 angles of convex octagons are congruent. Each of the other angles has a degree measure triple of each of the first 2 angles. Okay, and find the degree measure of the larger angles. Okay, so when in a polygon, the sum of the angle will equal to n minus 2. So n minus will give you a number of triangles and you times it by 180. And in this case, this is an octagon. So an octagon, the sum will equal to 8 minus 2 times 180. And so this will equal to 6 times that would give you 1080 degrees. Okay. And then in this case, he also tell you that so you need to find out the angles, okay, of the large angle. So you got angles that you got x, and the other one would be triple of these, which will be 3x. So there would be 6 of these. Okay. So in this case, the sum will equal to the x plus 6 times the 3x. Okay. And again, it's an octagon, so there are 8 angles, and 2 of them are congruent, and the rest of them would be 3 times these. So the other 6 angles would be 3 times this over here. And you can just substitute this into here. So 1080 equal to 20x divided by 20 divided by 20. So x equal to 54 degrees. So the larger angle is 3 times that. So 3x will equal to 162 degrees. So the larger angle would be 162. Okay, let's go to 221. So 2 congruent regular 20-sided polygon. Okay, I'm just going to draw the small portion of it. Okay. Share the side shown. So this is A, and this is B, and this is C, as shown. You want to find the angle measurement of ACB. So you're looking for this one over here. Okay. Well, what you want to do is you want to go ahead and draw. I'm going to draw this extension now, and I'm going to call this D. Okay. So angle ACD would be exterior angle. So angle ACD is the exterior angle, so it would be 360 divided by 20. Because let's see, 21. Yeah, 20-sided. So divide by 20. So angle ACD equal to 18 degrees. So this would be 18 degrees. This would be exterior angle, and by symmetry, this also is 18 degrees. So angle ACB will equal to 36 degrees. Okay, let's go to 222. Okay, it says equilateral triangle and regular hexagon have equal perimeters. Okay. So you have equilateral triangle, and you have a hexagon. Have equal perimeters. Okay, if the area of the triangle, so area of the triangle is equal to find the area of the hexagon. Okay, so that's what you're looking for. Okay, so the way to do this is that, so the perimeter, you can, again, there are 1, 2, 3, 4, 5, 6, right? So if you call this like 1, okay, or call it x, and this would be 2x, 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 right? Because the perimeter is 6x, this will give you perimeter of the 6x. And if you connect the middle, the midpoint, okay, so notice that each triangle will have side of x, okay, right? Now, if you do the same thing over here, if you divide into triangles, okay, notice all this will be have a length of x. Okay. So all you have to do is to get from here to here. All you have to do is, so this area is 2, and there are 4 triangles. So divide by 4. This will give you area of 1 triangle. Okay. And so K of the hexagon will equal to, so again, the area of this is 2, you divide by 4, this gives you area of each triangle, and then you times it by 6, because there are 6 triangles over here. So the area of the hexagon would be equal to, you keep one simple, so you end up with equal to 3. Okay, and that's it. Okay, let's go to 223. So 223, the picture is giving. You have 2 regular hexagon. And this is A, B, C, D. And this is E, and this is F. Okay. And it says the perimeter of ABCD. So the perimeter ABCD is equal to 44 plus 22 square root of 3. Okay, so you're looking for EF. So you're looking for this length over here. Okay, so what I'm going to do, since this is, you can, easier thing to just call it X, or I'm just going to call it 1. So if this EF equal to 1, okay, then this would be 1. And again, all this would be 30, 60 spatial triangle. Okay. And so if this is 1, and this whole thing would be equal to 2. Okay. Because this is twice as that. Again, just from this example over here. Okay. And so this is 1, this is 2, so this would be 1/2, this would be 1/2. And this would be 1. Again, this is 1/2. So this would be square root of 3 over 2, square root of 3 over 2. So the whole thing is 3. So by looking at these, you can see that the over here, if this is equal to 1, then you're going to get, so this right now, if EF equal to 1, then ABCD equal to 4 plus 2 square root of 3. Okay? But you can see that, this is 44, so you can see that this is 11 times as that, right? So this is 11 times as that. Therefore, EF would be 11 times that, so EF will equal to 11. Okay? So you just use a ratio. Another way to do it, just set this equal to X. Okay? So if this is X, and then this would be 2X, and so forth. Okay? So if you do it by variable, then EF equal to X, and you're going to have a ABCD equal to 4 plus 2 square root of 3 X, and you can see X is going to be equal to 11. Okay, so either way, so you can do it by just assign an easy number and you work, and you can use a ratio to get an answer, or you can just do a regular algebra, just set equal to X, and then you can figure out, you can solve for X after that. Okay. Okay, let's go to 224. Okay, from the area of a regular dodecagon, if the circumscribed circle has a circumference of 12 pi. Okay, so you have a circle, and I'm just going to draw a part of it. Okay, so dodecagon is 12-sided. Okay, so to figure out the central angle, a circle is 360. You divide by 12-sided, So you're going to get 12 central angles, so equal to 30 degrees. So this would be 30 degrees. Okay? And the circumference is equal to 2 pi r, and you substitute, you can figure out the r. So the circumference is 12 pi, so equal to 2 pi r, divided by 2 pi, divided by 2 pi, so r equal to 6. So this would be the 6 and the 6. Okay. So the area, so now to figure out this area of the triangle, so area of the whole thing would be, so just this one triangle would be 1/2 AB sine theta, so it would be 6 times 6 times sine of the angle in between. Okay, so you can, triangle, area of a triangle is 1/2 AB sine theta. Okay, so that is for one triangle. Okay, so the decagon is 12-sided, so you just times it by 12. Okay. And so now just work out the math. Okay. So this one cancel with this. Now sine of 30 degrees is 1/2. Okay, so 1/2 you cancel out with that, you get 6. And so K will equal to, okay, so it would be 108. Okay, let's go to 225. 225, find the ratio of the area of the circle inscribed in a regular hexagon to the area of the circle circumscribed about the same hexagon. Okay. Okay, so let's go ahead and okay, let's see if this will work. Okay, so you have a hexagon. Okay, so you got circumscribed, and then you have the yin circle. Okay, so you're looking for the ratio of the two. Let's see, you're looking for the areas, the ratio areas. Okay. Okay. So what you can do is, so you're going to call this big R and call this one small r. Okay. So by looking at that, I can realize all these are 30, 60 spatial triangles. Okay. So you can just, use the ratio.
Riley Matsuda to the upper school office, please. Riley Matsuda to the upper school office.
Okay, so you got 1, 2, square root of 3. Okay, so you have a triangle like this. So this is your small r and this is big R. So you can go 1, 2, square root of 3. Okay, so the area, okay, of the small to big, right? So small would be pi r squared to pi r squared. Okay, so the pi will cancel out, so all they just square the radius. So you're going to get 3 to 4. Okay. So 3 to 4, or you can write as a fraction, you get 3 over 4. Okay, let's go to 226. Okay, it says let S be the sum of interior angle of a polygon P, for which each interior angle is 7.5 times the exterior angle at the same vertex. Okay, so you have the x and you got 7.5 x. Okay, so again the interior angle is 7.5 times the exterior angle. And so you want to find the S. Okay. Okay. So you can see that because this is a straight angle, so that means 7.5x plus x will equal to 180. Right? So 8.5x equal to 180 divided by 8.5 divided by 8.5. So x will be equal to, if you simplify this, you're going to get 360 over 17. Right? Okay, so since this is 360 over 17, now the exterior angle, so 360 divided by number of side will equal to x, right? And so 360 over n will equal to 360 over 17. By just comparison, you can see n equal to 17. So this is 17 sided, okay? So there are 17 sides. So now to figure out the sum of the angle, you just go ahead and have a 17 sides minus 2. This will give you a number of triangles, and each triangle is 180 degrees. So the sum equal to 2700 degrees. Okay, and this does not have to be a regular polygon. Okay, it does not have to be a regular polygon.